Okay, in question 57, here what we're going to do is we're going to look at 4 different graphs that we've covered and see if we can identify which one's which. So, your choices are linear, quadratic, exponential, or cubic. Okay, well, let's start with the linear. Linear, you got the word line right in there, so which of these is a straight line? Okay, that would obviously be this one. So this is the linear. Okay, quadratic, remember the quadratic were the parabolas. Okay, that's a parabola. So which is the parabola? That's this one, that's the parabola. So this is the quadratic. Okay, exponential. Exponential is the one that was like the money where I said we could turn $1 into $1 million in 20 days, and it starts to grow slowly and then increases quickly. Well, that's this one. It starts to grow slowly and then all of a sudden skyrockets on us. It's going to just shoot straight up. So this is the exponential. Okay. And then the last one obviously has to be the cubic. This again was from the polynomials. Remember, this was the disco function where it went down to the left but up to the right. That was the cubic. Okay? So this one you're just going to have to match the terms with the correct graph. So you have a couple different choices there. On 58, here it says use your graphing calculator and a table below to find a model to represent your data. So this is where we did the scatter plot. So we go to Stat, go to Edit, and then we want to clear out this old data. So go to column heading, hit Clear and Enter. Column heading, Clear and Enter. And then let's enter our data. So this is -1, 0, 1, 2, and 3 for our x's. Our y's are 2, 1, 2, 8, and 18. Okay. And then what we'd like to do is see what this looks like as a plot. So hit second. Sorry, don't hit second. Go to y equals. Make sure first of all, make sure your equations are all cleared out here. We don't want anything else on our graph here, so these are all cleared out. Okay, and then go to plot 1 and turn plot 1 on. And then we're going to hit graph, but this is probably a little hard to tell, so let's hit zoom. And this one was, since it's the stats, it's zoom stat, which is option 9. So we hit zoom 9. Okay, so now what we're going to look at is which model is better. Okay, well, which of these graphs from above looks like it closely resembles this one? Is it an exponential? Actually, our choices are linear, quadratic, or cubic. So it would have to be one of these 3. Okay, so is it quadratic? Looks like it could be. Looks like this could end up coming back up. Linear, does that look like a line is going to go through those points? Nah, a straight line doesn't look too good. Cubic doesn't look bad, but cubic's going to turn and head down, and it looks like this turns back up. So let's see if we can create a quadratic line or curve that'll go through this. So go to Stat, go to Calc, go to Quadreg, which is number 5, and then this is where you hit second and the number 1 to put L1, comma, second and the number 2 to get L2, comma, go to vars, y vars, function, so let's select y1. Okay, now this is going to calculate out when you hit enter the equation, which we're not asked for, we're just asked to identify which. And now if we hit graph, that looks pretty darn good. Okay, so here the best model is quadratic. Okay. All right. Now we're going to look at some OGT questions that we covered. Here we covered how to find 5 factorial on your calculator. So that, let's clear this, let's go back to our home screen, clear this out. So factorial was under math, so first we have to type in the number 5, and then we're going to go to math, and that's over at probability. My factorial's number 4 there. So 5 factorial, that equals 120. So this is 120. So there's your answer there. Okay. Now we want to find out this calculation, so let's see how to plug this into our calculator. We're going to go 4, go to math, go to probability, go to option number 4. That's 4 factorial divided by, now because you have multiple things in your denominator, you're going to need to throw those in parentheses. So in parentheses, we've got 2 math, probability, option 4, factorial times 3 math, probability, option 4, factorial. Hit enter, and your answer here is 2. Okay. Now, we could have done this one without the calculator. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1 times 3 factorial is 3 times 2 times 1. And we could have just gone through and canceled some common factors. This 3, 2, 1 cancels with this 3, 2, 1, which leaves you with a 4 over 2 times 1, which is 2. 4 and 2 cancel, which leaves you with a 2. So you could have done that by hand as well. Okay? And remember, on number 59, this would have been 5 times 4 times 3 times 2 times 1, which if you multiply all this out, you get 120. Okay? We had a couple more from that unit. Question 61, we want to find the value for the permutation and the combination to show that those are actually different. So with the permutation, you enter the 7 first, go to math, go to probability, permutations, option number 2, and we want permutations of 2, so 7 permutations of 2. So that number looks like that is 42. Now let's do the combinations. 7, go to math, go to probability, go to option 3, and then we want to do combinations of 2, so there we've got 21. Okay, so recall that here permutations is when you're arranging items and you're worried about the order. The order is important. So on question 62, does the order of the arrangements matter in a combination or a permutation? So the answer to that would be a permutation. The order is important in a permutation, which is opposite of what you would think, because combination, your lock's a combination lock, and the order is important. However, they're mislabeled. Okay, so see how permutations, there's more options than there is with combinations when you're using the same numbers. That's because if the order in which the numbers are listed are important, like here, if the two numbers you're picking is 1 and 2, well here 2 and 1 are different answers. Well here, if you select 1 and 2, it's the same answer. Well, 2 and 1, 1 and 2 is the same thing. That's why there's half as many, because these are different here, but on this one, it's the same 2 numbers, so you have less options. You actually, in this case, have half as many options. Okay? So on 63, we want to decide which one we're going to use and then how many we have. So you have 7 houses for sale. How many different orders can you view all 7 of the apartments? Okay? So we only have 7 things, and we're going to see all 7. So, and the order is important because we want to see how many different ways we can view those, the sequence. Do we want to go to this house first, or that house first, or this house second, this house second? So this would be 7 permutations of 7, or because the numbers are the same, this would just be 7 factorial, because we have 7 choices for our first house, but once you go to that house, you only have 6 houses left that you can see. After you see that house, you only have 5 choices you can see. Then 4, then 3, then 2, then 1. So you can work it out as 7 factorial, or work it out as 7 permutations of 7. So if we do that, we can actually, we already have that in our calculator, 7 sorry, let's switch that. 7 permutations of 2. Let's change it to 7 permutations of 7. We get 5,040. Or if we do 7, go to math, go to probability. Option 4, you see those are the same numbers. Okay? So this is 5,040. So no matter how you do it, you get the same answer. Okay? So that's a review of combinations, permutations, and also the different types